Good afternoon, everyone. It's 12 o'clock, real time here on the East Coast. Welcome to the Dorman Lunch Learn. My name is Truglia. Today we'll be doing DVOM, using it to diagnose electrical circuits. We'll do some hands-on with it as well. But first, we're going to talk about here, this webinar is a great review for the seasoned tech, an excellent starting point for someone that may not know as much as they need to know about what tests the meter can perform. So we're going to do meter usage, the DMM, digital multimeter, all about the meter, circuits and circuit testing. And the most important thing, VD, voltage drop. It is the most important thing that you got to get out of this webinar because voltage drops cause tons of problems. So for years we used things like this, a test light. Not really good to use on today's car because it has low resistance. And low resistance, if we use that on an airbag circuit, for example, that'd be like putting a jumper wire across and an airbag can pop. A logic probe, where most people don't know what this thing does, this is actually better than a meter. On a square wave signal, of course, it'll show you low voltage green, high voltage red, and that could be a 5 volt or 12 volt. And switching is the pulse. So when it goes from high to low. A meter is going to average. It's 40 times a second update rate. All of these scopes here, whether it be the newer Snap-on, the older one, or a Fluke, they're about 25 million plus samples a second update rate. I have one scope, a Fluke 196C. It's 1 gigahertz. That means it's one, not million, but gigahertz samples, right? And then the old Vantage is nothing more than a meter, about 40 times a second update. So whatever flavor you have, a Fluke or a Snap-on type here, Blue Point, or an OTC, or any other brand, here's what you really need to know about the meter. Number one, when you look at the symbols, when we turn it, we need to know what every one of these do. For example here, this is AC voltage. What are you going to test with AC voltage on the vehicle? Well, you can test a bunch of stuff, right? We have crank sensors, we got blower motors, we have anything that's going to be cam sensors, anything ABS, not all ABS by the way, or crank and cam sensors are AC. Some could be Hall effect as well. But for those AC signals, that's what we'd like to use. We'd also like to use that on what? That's right, the battery, right? The battery or behind the alternator for diode testing. Very good, okay? Then we got DC, 3 dashes and a line. This is the most commonly used, okay? Millivolts, we'll be talking about that. Millivolts DC. Here's where you're going to get VD, the voltage drop reading. Very, very important to get that voltage drop reading, okay? So keep that in mind. We're going to be doing that. Ohms, the resistance of something. Diode check. And what's the difference in voltage? These all take 9-volt batteries in there. What's the difference between ohm output and diode output? Anyone know the voltage level? If you know the voltage level, type that in. I'll give you a second while I move my screen so I could see more stuff. So go back to the slide. So what's that difference? Anyone know that difference? Okay, someone has 0.2, 0.7. Okay, first what I want you to do is put in what voltage actually comes out on ohms, because you're putting a voltage out, okay? Put that in, and we'll restart that. You can get a free t-shirt for this. So put in what's the difference. Someone there in the first person up. So there is, I can't tell the guys, Guillermo, 0.3 to 0.7, okay. 6 volts on a diode. We're getting close. So when you look at 1.5, no one seems to have that right answer there. Now again, based off a full 9-volt battery in the meter, you're roughly about 2.5 volts, you may want to write this down, on ohms, and about 7 point something volts on diode check, okay? So how do you tell that? You put your meter, 1 meter, borrow a friend's meter, one on voltage, and then put the meter you want to test for its output, first on ohms, and then go to diode, okay? Now, the reason why I bring that up, when we get into a hybrid or EV meter, those can put out over 1,000 volts with 4 AA batteries in it, okay, with a boost transformer. So good try there. Milliamp DC, we got to be careful there. We're in this jack. Do not use that little MA jack because that's only 400 milliamps. This is 10 amp jack, 1 lead in the common, and that is your voltage jack. So those are the symbols and they are important. And as you can see here, courtesy of Fluke, if your meter is one of those cheapies, look what happened to this meter, how it burnt up. Look at the guy's fingerprints, okay? Now, if this is on super high voltage, this guy is dead, okay? Dead. So when you buy a meter, one of the things you want to look for, and it's going to probably not come up on the camera, because this thing is, I barely can see it here. It's going to say not only Fluke, but it's going to say Cat 3 certified. Whoa, whoa, you got it. Look at that. You see that Cat 3, 1,000 volts right there? Very good. And there's the categories. So this is super important when you have ends, whether they be alligator clips like this, okay? The lead itself is going to have the certification on it. I don't know if that'll come up, but if it does, that's great. Yeah, look at that. You see that? Cat 3, 1,000 volts. You want to make sure you have the right stuff so you don't get hurt. And, you know, nowadays, obviously, with so many electronic things around, whether it be hybrid or EV, you want to make sure when you buy a meter, the leads and the meter are certified. You don't go to some of those places, I'm not going to mention names, but the cheapy places where they got those great fuses out there, right? So anyway, be careful with that. And here, courtesy of Fluke, this is what it basically means for Cat 1. You're real far away from the source. Cat 2, you're a little closer to the source. Cat 3, you're going to be near that box. And when we work on a car, we're going to be near that electronics on that high voltage vehicle, either hybrid or EV. And Cat 4 is basically you're on that incoming line of voltage. So that's what it all means. When you look at an ohm meter, you know, a lot of people don't do this, but you want to zero it out. Now, many meters like this one here, this is a Fluke 88, a newer style than the one pictured, okay? This is a Series 2, I believe. Yeah, Series 5, excuse me. But they updated these. So when we put this on ohms, it tells me OL because I'm not connected. So I'm going to take both of the leads, and here's my alligator clip. Just put this down for a second. I'm going to put the alligator clips together, and now I'm reading resistance of the leads, okay? So how do we get rid of that? Oh, don't have a 0 button anymore. Well, that's okay. You got a button here that says relative delta. This is the button if your machine doesn't have a 0. We're going to hit that, and you see how that turned to 0? That takes the resistance out of the leads. And by the way, when you move your leads around, they're big antennas. So if I put it on voltage, you know, on millivolts, you're going to see stuff move around. And especially if I put it on AC and I'm not connected, look at, oh, I don't think you can see that too good. Let me put the light on. Look at those readings. That's on AC voltage. This is on DC voltage. That's called ghost voltage, by the way. Ghost voltage, okay? Any questions on zeroing the meter? For hybrid vehicles, what category is recommended? 1,000 volts Cat 3. That's what you want to get. So that is a good question. Cat 3 leads is what you would want to purchase. And the meter has to be Cat 3, not just the leads. All the ends, everything must be. And thank you, someone there put 1,000 volts. I think it's Brett. Okay. Very good. So now when we look at this, we're checking resistance, and I want you to look at the windings. So I'm gonna blow this up a little bit, and then we're gonna see which one would be the highest blower speed. Now, watch me. This is number 1. This is number 2. Everyone good with that? So again, number 1, number 2, or number 3, which one is high speed? Okay, you had a sound, the breakup, and we're back, no problem. Number 3, okay, so number 3, why don't you type in the first guy there, type in your email, we'll send you a Dorman shirt. Now, this would be a lower speed right here, because more resistance, right? So that's your high speed, this one here. Number 2 is the medium speed, and number 3 is the lowest speed. What is this right here? Does anyone know what that is?
A fuse?
No, not a fuse. Okay, Greg, good, a diode. So Greg, why don't you throw in your email there? So that way we don't backfeed. That would be a diode in there. Very good. Very good. Okay. Moving along. Here we got a coolant sensor and other NTCs, negative temperature coefficient. So anyone, could you explain a negative temperature coefficient? What's that really mean? What's that mean with voltage, and what's that mean with resistance? And if anyone could type that in there real quick. Okay. So we don't see anyone typing that in. All right, we don't have a lot of time to spend. So when it's cold, resistance would be high.
Temp goes up.
And temp, oh, okay.
Hold on, I lost it.
Resistance, you're killing me. Resistance goes down.
Hold on, I gotta find it. It's touchy, I'm sorry.
Okay, Doreen's trying to find, you gotta go the other way, I think.
Answer it.
Okay, someone gave us an answer, and if it is the correct answer, and by the way, the handout is in there as well, if you're looking for a handout.
Temp goes up, resistance goes down.
Okay, so that one, if you start at a -40, the voltage would be high. Voltage goes down as it heats up, and same with resistance. Voltage and resistance are both high, so that would not be correct.
How about
Both of
temp
them are going
down,
to change.
resistance down?
No. Okay. So the correct answer is on an NTC, a negative temperature coefficient. When it's cold, the voltage and the resistance are high. As it heats up, they both go down. So on your scan tool, like a number, if it was -40 out when I worked up in Alaska, we would see 5 volts, okay? And obviously, when I work in Phoenix, Arizona, and it's 100 and something degrees out, we're going to see very low voltage in the millivolt range, right? That's what you'd see out there. So you could take your lead here, and when you take your leads, you can connect to them and see what the reading actually is on your meter. Now, when you're going to use the amp part of the meter, here's where everyone blows the fuse. So when we go like this and put your meter on, if you have a good fuse, you hear that? That's not my heart ticking. Could be, but it's not, okay? That means the fuse is good. And Fluke is warning you, hey, you're on voltage. If you put this parallel, like across a battery, negative and positive, you're not going to get any more of that. It's going to be dead. You blew your fuse. Very common. I do tons of live classes here, and I would say over the years, oh my God, the amount of blown fuses, okay? People make mistakes. When you're done, pull out. So don't leave it in there. You're done with it, put it away. But you should be on current. Now, there are some meters, when you turn this, it actually shuts off, so it doesn't allow you to put your meter lead in there. There are a few meters out there. Fluke owns, by the way, the old OL. Now, here's another thing. When you use this at 10 amps, here's what I'd recommend you make. You see this here? 2 clips, okay, and a 10 amp circuit breaker. I use this in series, and I know someone's going to go, it's not going to work. It works. I've used it a gazillion times. Use it in series. This will heat up and pop before your fuse pops, okay? So you get an ATC fuse holder. You get yourself a 10 amp circuit breaker. That's all is in a circuit breaker, little type thing there. And all my guys have this. That way, if they're going to use their meter in series, okay, a straight line, they're actually going to not blow the fuse in the meter. Fluke fuses are quite expensive. There are other meters out there that maybe are not as expensive, but this one is. So we're done. We pull it out of the hole because we'll be doing some stuff on the board with voltage, and we make sure it goes in the voltage jack. Any questions on that? Okay, unless it's a snap-on meter. You're killing me moving that. Cool if there was a built-in circuit breaker. Okay. Yeah, if there was a built-in circuit breaker, that would be good. Now, you know, Fluke meters and a lot of the meters that you see out there on amperage, it tells you it's a 20 amp. You can't pull 20 amps. They're all 10 amps. You may be able to, by accident, go on a circuit that's pulling 20 amps. You got seconds before it goes poof. Does that make sense? Seconds before it's like, we're done and out, okay? So here it's a seesaw electricity. When resistance is low, current is up, okay? Voltage should be right in the middle. When ohms are high, amps are low. So basically, remember this in your head. If you got a computer that is blown, right, you better make sure that you don't have anything in there like a solenoid, not a sensor, a solenoid, a steel bar with windings, anything that has low resistance will make high current. And once you get over 1.2 amps, 1200 milliamps, for more than 6 milliseconds, you'll burn it. There are some exceptions like diesel injectors, that's on a special circuit, GDI, gasoline direct injection. But for the most part, once you get past 12 milliseconds, 1200 milliamps for 6 milliseconds, that's when you're going to have a problem. You're going to burn something out. So don't randomly throw a computer in. Check the resistance of something. And let's not forget, you could also have mechanical resistance, meaning if that injector is clogged and something is pushing against it, well, that could make amperage rise, right? That's mechanical injection, amperage rise. You could have a fuel filter, even if it's in the tank and the fuel pump is trying to push fuel up and the current is going to go up. Why? Because it's being physically blocked. Does that make sense? Or we can just have the armature binding up on that fuel pump and causing amperage to go up. Those are all things, right, that happen. An electrical circuit is basically, we start here at the battery post. Everything flows from negative to positive, comes through here, goes through the load, whether it be a light bulb or anything else. And because this is really a short circuit going on there, isn't it? When you look at that, hey, that's connected. Yeah, and it's really arcing if you ever look at an old light bulb, and it's going to create heat, the result of electricity, but the resistance is enough to where if it was equal value of these two terminals coming up, then it would totally short out and either burn the wire up or burn something up. If we had a fuse in there, pop the fuse, right? When we have an open circuits, all the years I've been working on cars and running businesses, no one ever came in and said, hey, gee, I have an open. It's always, they call it, I have a short when they got an electrical problem. That is really not the case. It is not a short, okay? It is an open. So opens are a break somewhere in the wire and or component, and you got to find out where that is. Does that make sense? You got to find out where it is. So if we had 12 volts here and we go through and we had no voltage drop here, and this is all complete, you would still have at that open circuit right here 12 volts. Obviously, we'd have no voltage here. That's what an open circuit does. A short to ground, once we go through, negative to positive electrons flow through the battery, comes up to the positive side, goes across. We did not go through resistance. We went through equal resistance, meaning the wire that shorted, that wire is going to burn up or a fuse would blow. There's another short called a short to power. A short to power, you put the lights on and maybe the wipers pop on. You put the radio on, maybe your horn blows, right? Those are wires that are rubbing together, a short to power. Any questions so far? Oh, someone keeps their meter for amps only. Okay, very cool. All right, now series circuit. Well, you remember if you bought old Christmas lights, right? If we had two bulbs here, another bulb in series with this, if either one of those bulbs were out, well, none of them would light, and that'd be a problem, right? Reason being, again, we're going to have negative to positive coming out, going through the switch, and if we had a load here that had an open, or if that was good and you had an open here, you wouldn't have a ground. It needs to be complete. Now, on a parallel circuit, or on series parallel circuits, you come out, you got a separate ground, so if this bulb was blown, it still has a path to flow here to go to this particular ground, and that light bulb would still be on. That is a much better way of actually allowing electricity to flow, correct? And that's what we would use. Now, another big problem here, and we're doing this in New York Minute, right? Because we got a lot to cover, parasitic draw, meaning the battery drains down. Some people have real problems with this. Let's take a look here. Well, the old test light way, oh, the light's illuminated. You don't know how much that light is. That bulb could illuminate for a couple of 100 millivolts or less, okay? So it being on, you're not going to tell me how much voltage you're losing. A meter is great, and there we got a fused meter. The only problem is once we remove the cable, we could have a problem with relays letting loose that was sticking, right? So you would need a shunt or something to make sure that there's not a problem, right? And an amp clamp is the best way to go, and you want to be around all the wires. Now this amp clamp, a Fluke ADI-110, is too small to get around most of the battery wires. So we're going to show you. Now, again, this is one method you could do. If your amp clamp can fit around and the jaws could totally close. And by the way, always zero the meter. Okay, that means the amp clamp gets zeroed before going around the wires. Here's the one I recommend, probably set you back about 700 plus bucks. This is what we use in the shop, the articles I've written in the past for Motor Age, and we do have more coming. You can see this is a Fluke I-30S. I like in I-30, S like in Sam. This is very, very accurate on low current draws. That's the one I'd highly recommend. We use that along with thermal imaging, and it makes life a lot easier, okay? How do you guys do stuff out there, okay? So someone has VD across the fuses. Well, we're going to get there and show you here when I did some work with Snap-on. This is a way to check for parasitic draw. By the way, this has a fuse on the, I think it's the right side, has a little 10 amp type fuse in there. Look up always what the normal draw could be, and are there any timeouts? A little note here you should know. What is NVLD? It's not a new disease. No, it's not Fauci telling you he has something new coming, right? NVLD, natural vacuum leak detection. The pump could be on with the key out of the car, okay, or the fob, not in the car. It's going to run at a certain time. Now that will come up as a parasitic draw, so you want to make sure everything is timed out, okay? Here is what we were talking about just a second ago. Someone says, hey, how about doing VD on the fuse? Well, that's okay, but make sure a reading you get is solid. If it's bouncing around, that is ghost voltage. That's a problem, meaning you're not on there. There's a little video I'm going to play for you here in a second, okay? And here it goes. Checking parasitic draw with VD. How to do parasitic draw with your voltmeter on millivolts DC. Notice we're at 0. He's on a fuse, but go off the fuse for a minute and show us ghost voltage. So if you got ghost voltage, you see it bouncing around, you're not connected. Like, go near the fuse, but don't hit the metal part. Go near the fuse. So if you near the fuse and you're not on the pin, you're still going to be bouncing around. Now go on the pin. We'll get a solid 0. Now we're going to open the door up because there's no parasitic draw, but watch what happens when you got a load on. There's the door open, the dome light. The dome light is on, the door panel lights are on. Come back around on his car, and we have a millivolt voltage reading. That means we have a parasitic draw. Go shut the door, Solomon. We're still on there. See where we're connected? Now watch this. And notice where he was on the
Look at
fuse.
that,
Timed out. Okay. So it has to time out. Sometimes it'll stay up longer than others. So still doing some bouncing around, right? Stay on the pins. See, he went off the pins a little bit because he was looking. When you see bouncing around, you're off. So watch this now. It's probably going to take, we're starting to drop, 0, 0. Yeah. Now you know it's timed out. How long did that take? Probably 20-something seconds or so, 30 seconds,
30
right?
to 20, yeah.
So this is how you do a parasitic draw, okay, when someone's battery is going down, by doing voltage drop on the fuse. You got to be in to the fuse correctly. Now a little note about that, not every fuse you can get on. So I'm not a big fan of this. This was pretty popular about 3 to 5 years ago. You know, there was companies out there doing classes on this, just on voltage drop from the fuse. This goes back to the 20s and 30s, all right? It's not rocket science. Now, there's also charts that'll tell you, and even Curian has a great meter with a chart, and it'll tell you the amount of voltage drop, because you can't have voltage drop unless a load is on. They will give you something on that circuit saying maybe there's a light bulb on or something else. Basically, if I ever use that method, if I see I got a reading, I got a problem in that circuit, I'm going to research what is in that circuit, right? And then look for it. But that's where a thermal imager and an amp clamp, in my opinion, is way better, okay? So here we got 2 meters, and I want to show you that the headlights are on. This is on a Crown Vic police car. Notice we have a meter in series. We're at the battery here. We have the other part here with the cable off. Don't worry about the amp clamp. There's the 10 amp fuse, or breaker rather, lifted up so you can see it, and it's going through the meter. It's telling me I'm pulling 14 amps, 210 milliamps. We also have an amp clamp here. This is an inexpensive amp clamp from PDI. Not bad, but you can't get this around all the wiring here, right? So we're just showing this in a class as an example. We're on voltage, we're in the voltage racks, not in the amperage jacks. So with an amp clamp, you go into voltage, you put your meter on, and we're on voltage. It has 1.456. Now look at that again. 1.456. How much amperage am I reading? The first thing you would need to know, and if you get the right answer, I would basically give you a t-shirt. So I want you to look at it again. Now here you got 14.21. Here you got 1.456, and we're in the voltage X. How much amperage are we pulling? This is for a t-shirt. 1.456 amps. Okay. The guy Raymond, 14 amps, 560 milliamps is correct. Now, why, Raymond? Besides giving us your email, why did you say that? If I covered the 1, all right, and it says 456, every 100 millivolts, that would be 456 millivolts. Every 100 millivolts equals 1 amp. Okay, so that would be 4 amps, 560 milliamps. How about the number 1? How much is the number 1 worth? 10 times. Very good, Steve Layden. Excellent. Steve, why don't you throw your email in there as well? We'll give you, both of you guys, a t-shirt from Dorman. Very good. And thanks for being on this, Steve. So if that was a number 2, that'd be 24 amps, 560 milliamps. Remember, there's always the 0 here that doesn't show up. If you have a 5 decimal display type system, I do have a couple of meters like that, then you would see that. When it's not there, the right way to tell the hotline is that's 14 amps, 210, and if you're using an amp clamp, that's 14 amps, 560 milliamps. Great job, guys, great job. Now, when you're really doing VD under a car, and here we have another police cruiser, and on this one, you could see how corroded this thing looks. It was near one of the salt pits, okay? And we are connected with the negative lead up to the power probe negative that is connected to the vehicle's battery. They're cranking it over, not in this picture because look at our reading, 0.003. When you do voltage drop, you see it says no load on the circuit. Very important, slide 25, to write that down. It's not loaded. You don't do a voltage drop when it's not loaded. Look at the difference when it's loaded. Now you got 320 millivolts voltage drop. Same place, but now we loaded the circuit. Does that make sense to everyone? Okay. So you have to load the circuit. And we're going to do this live on the board just in a little bit here. And here is the positive side, 960, 0.96, 960 milliamps on the positive side. You see I have this, positive to the most positive. This is the power probe connected to the battery. The negative is on the positive lug up here. And we crank it over, and that's the reading we're getting. Okay. Now, look at this. I was teaching a class down in Florida, and I just happened to have the scope with me because I was going to be doing other classes as well. And make a long story short, the guys couldn't get the concept of voltage drop with the meter. So this is a little video. It does stop, and I want you, when it stops, I'm going to tell you to look at something, okay? Watch this, please. Okay, doing voltage drop on this fuel injector. We have the meter hooked up. We're doing it on the feed side. We can see on the lab scope, we got a voltage drop right there. Let's turn the switch off. So you see that right there? You see that voltage drop? Watch this as it starts up. But look at the scope. Big difference. So now there's no voltage drop, or very little. We can hear the fuel injector working. So there's our voltage drop using a lab scope. Amperage and voltage. Here's our E-trainer board. And now we're going to press this button here or slide it over with no voltage drop, no resistance. Look at the injector. Look at the pinto bump. Look at the injector going down the ground. Normal versus, can you flip that switch? Look at the difference. That's with a voltage drop. Now that really helped those guys in that class get the concept of voltage drop because they were able to visualize it. When that is not down the ground like here, it should be down here, right? Well, that injector can't supply enough fuel. We proved that with amperage. The amperage should be up here at about 1 amp. It's not because there is VD, voltage drop. It could be on the feed side, meaning the 12 volts going in, or 13 or so, system voltage, or it could be on the ground side. This is what you have to understand when you're checking the circuit. Don't just check one side. Check both sides, and we're going to show you that live in a minute. Here's another example of voltage drop. It's battery voltage here. I'm going to show you what a bad voltage drop is. So we're at the post of the battery. He's going to stay on the negative. He is then going to touch the engine block. So that's usually a ground. Well, scratch it in. Hey, we're reading 12 volts, 630 millivolts. What's happening is electrons are flowing through the battery, negative, where he has the black lead on a post, going to the red post, flowing out, and then going to the engine ground. If he takes this red lead and goes to the cable that is off, he still has 12.65 volts, right? But yet, if he puts that back on the battery, please put that cable back on the battery, go all the way down, and then I want you to touch the engine ground again. Go to the engine ground. Negative, positive, first baseline, negative, positive.
Okay.
He's there, he's here, please touch the engine. He's reading nothing, look at that. Okay, take it off right now. Take it off one more time. Pull the cable up, please. Do the same thing, baseline it. Nothing on the meter, he baselines it. You got 12.6. Please go back to the ground on the engine. You're reading full battery voltage. Go to the cable end. You're reading the same thing. It's because electrons can't go back to the battery. So that is a good example of voltage drop. That used to be a big problem on a lot of Fords that had the cable stripped going down to the frame for body ground. That was also common on some Toyotas and some Hondas that use that. The battery would gas, the corrosion and oxidation would go through the cable down to the frame where it was grounded, and that's where you would read full battery voltage. And let's not forget another thing. I was just showing my guys yesterday in the shop how to check a battery to see if it needs a service. Go to the battery post, negative and positive, and then take the red lead and put it on the battery case. We read over 9 volts on the battery case. And that means that battery is gassing. Now, of course, you got to check the whole condition of the battery, but if you get some baking soda, put it on a rag, and be careful not to get anything down if it's a vented type battery, which not many have any vent holes that can get anything down now. But wring it out, clean it up, and then you can put protective seal on it and you won't have a problem, okay? If the battery passed all the tests. And here you can see with one strand, you know, you may see that you have a good ohm reading, but when you load that circuit up and put it on voltage, what would happen to that one strand of wire? It would burn out, wouldn't it? Sure. This is a permanent end, and here's what we see a lot come in. This is VD ready to happen, a problem that's going to be an issue. These are all VD problems. You see this? You see that? You see this burning up? You see this melt on a Volvo? All this is voltage drop, poor connections. Poor connections, lower strands of wires, all of those are voltage drop issues. Look at this relay. 87's a load, hot from the battery. You jump across it and you got 3 volts voltage drop, 3.6. 3 volts, 600 millivolts voltage drop. That is a lot. Whatever that relay is controlling, whether it be a fuel pump, lighting, or anything else, of course it can't work to its optimum performance. It would be impossible. Why? Because some of that electricity is being stolen, okay, being lost. Here was a good one that came into the shop, and probably our last little video here, and hopefully this gets the idea. The most important thing is voltage drop, and then before you know it, we'll be on the board. Watch this carefully. Here we're at the battery post, and we're at the battery lug, a voltage drop of 2 volts, 300 and something. Let's see when we try to crank it over. That's just with the key on. Whoa. Did you see that spark fly? Wow. Let's check that out. I even seen the spark come out of that. Oh, we didn't min-max it. Damn. Bill thought I min-maxed it. I thought he'd min-maxed it. Yeah, let's try it one more time.
Ready?
Okay, so right now it's only at 1 volt. 2 volts, there's 2.4, key on. That's over 2.5 volts voltage drop. So this is what happens when you put these lousy emergency ends on. Both of them are going to need to be replaced. Now that guy lost faith in the shop he was going to probably put the ends on. We don't know that for sure. But he had brought his car back a couple of times because he had gotten stuck. He got fed up with them, and when he came in, we're like, this is a no-brainer. But people don't know what they don't know, right? No one is stupid, but if you don't update, you will evaporate. And that garbage that's being sold, parts stores should even sell that junk. That is pure junk. You need to have, we have a whole kit that makes ends, we make wires, we could do the whole thing, or buy a new cable, right? The right way to do it. Now here, this is another thing. Now Dorman makes, this is a TRW box, as you can see. Dorman makes a lot of this, and this was a big problem on Volkswagens, where you had from here to there, a voltage drop of 200 plus millivolts. Well, you go, that's not bad. It's bad if it's in a short section. Look how close this is. We're talking from here to there, you got 200 millivolts voltage drop. When people put a new box in and they didn't cut this back and put a new connector on here, the problem was not all the strands of wire were bare. There was still insulation on it. This was a problem at the factory. They crimped it, and now you had, rather than, I'm going to make a number up, 100 strands of wires flowing the current, maybe you only had 75. And when it was new, there was not a problem. As it got worse, some of the strands burnt away. Now maybe you're down to 50. Remember, the result of electricity is what? Oh, that's right, heat, right? And that's what melts the box up. So when people go, oh, you know, that Dorman part's a real piece of crap. Well, they're absolutely wrong. The Dorman part don't suck. You suck because you don't know how to do a test correctly, right? And I don't mean to insult anyone, right? But this is stuff that we normally see. People will blame everything else, but their testing is flawed. Make sure your testing is correct. Okay. And voltage drops are loose connections, corroded connections, undersized wires, or broken cable strands, all equal low voltage, low current at the loads. That is the important thing to get out of voltage drop. Any questions out there before we start moving on to the board in just about a minute? So here, easy thing to do with your meter, go to the battery, check DC voltage. You can put a scope on it, would be the same thing. Switch it, and you can see AC ripple. Now, most of the time, you can't get to the back of the alternator like this, right? Go directly to the battery. The battery's a buffer. Rather than 500 millivolts, now a lot of these vehicles should have lower ones. Now, some new stuff that's crazy, some new ones, it's okay momentarily to go over 500 millivolts. You always want a hot motor when you're testing. Loads at a stable, not turning them on and off, a stable condition, whether you have the wipers, rear defroster on, the air conditioner on, got to be stable. And those are the readings you should look for. Your Midtronics, your Snap-on, your Associated, all those electronic battery testers that do conductive resistance, they all test and show you if the diodes are good or bad. They basically program that number in there. If it goes over it, they're going to flag it and tell you got a diode problem. Remember, parasitic draw could also be from bad diodes in the alternator. Don't overlook that. There's many things that maybe you've seen if you watch some of these videos before, that you have a issue with a thermal imager showing you that. Okay. In the radiator, connect the negative and then go in with the positive lead here. Don't touch anything. You can see that antifreeze kind of corroded. If you got more than 300 millivolts voltage, and by the way, here is a display with 141 millivolts, because you see you got 1, 2, 3, 4, 5 display rather than 4 display. And if you reverse the leads, look at the reading you get. You're getting 12 volts, 373 millivolts, because you put the negative lead in the radiator. The wrong way to do it. Proper testing. Negative lead in the battery, red lead into the coolant. And that's called electrolysis, right? Now we're going to leave that up. Let's go over to the board. And let me turn my monitor here so I can see questions if you're asking me at the right time. Okay? So here we're on. I'm going to turn the meter on. And the first thing we want to do is baseline. I'm at positive and negative of the battery. I got 12 volts, 350 millivolts on that meter. Now notice I got a bright bulb, right? And I got a dim bulb. So you could do voltage drops two ways. A lot of people are going to go like this. And let's first go to the good circuit here, or believe good. I got 12 volts, 310. So now I got to do the math. 12, 310 minus 12, 34. Well, that's not a lot, right? You can subtract that, or you leave the positive in here, take the negative, go to the next positive of the circuit. You see you got 0.4. You want to really split hairs, put it in millivolts, you got 38.9 millivolts voltage drop. Now that's only one side of the circuit. Now let's check the left side, the ground side of the circuit. Go back, make sure you always have 12 volts. Take the red lead, go up to the ground, and I have, notice it says OL when I'm on millivolt scale. So I got a problem here, right? I go down, I got a voltage drop reading of 1 volt, 490 or 500 millivolts. That's a lot. That means I got a ground side problem, correct? Now let's look at this other bad circuit here and do its ground side. Look at that. How much voltage do you have there? You got 6 volts, 630 millivolts. That's a hell of a lot of voltage drop, isn't it? Now, you never just do one side. So now what we're going to do is come back with this, go to the positive, come up and go to the positive side of the circuit, and we are reading 185 millivolts voltage drop. That's acceptable, right? Everyone agree with that? So now we're going to kind of prove something out here. I'm going to take a couple of jumper leads. And let's go back to baseline first. Let's go up here and see that we got that 1 volt. I got to take a pin here. And what I'm doing is I'm connecting to this other ground down here that comes down to the battery. And just keep that right there. And there's my voltage drop is now gone. We could then move this to the bad bulb, OL, we're reading 6 volts, right? So if you want to prove out that you have a bad ground, I'm going to take this, put this jumper wire in there. Yep, of course, pops off the pin. But I think you're going to see right away the bulb is going to illuminate. Come on, fingers. The bulb is going to illuminate really nice, and even the other bulb lit up. Let's see what that voltage drop is now. Now we're only at 21.6 millivolts. So that bulb could not work right because what does it have? A poor connection. Does that make sense to everyone? Any questions on that? Is this helpful? Type in a Y or an N if it's not helpful. Y if it is, N if it's not. Okay? Now, I also want you, I always say in my classes, your brain, your eyes, your ears, your nose, your hands are super important tools. I'm going to want you, and thank you for typing that in, I'm going to want you to listen to something now. Listen to that. And listen to that. There's the problem. No problem. So now the motor is an issue. The motor is running. Let's baseline our meter. Make sure we got good voltage. We got system voltage, 13 something. Someone said they couldn't hear that. Were the rest of you able to hear? I'll do that again. Pay attention. Maybe put your sound up. You don't hear the difference? No problem? You can't hear it at all? It's pretty loud. Okay. Let me try moving the mic there maybe. Okay. So I'm right near it. That's no problem. Problem. No problem. Problem. Well, hopefully you were able to hear that a little better.
That didn't help.
Okay, maybe noise canceling, I guess. Who knows? Steve says it's okay. Maybe the rest of you is, I don't know. But believe me, it's making noise. So when we try to diagnose this problem now, we're going to go to the positive side. So we stay in the positive. Everyone see where I am? I'm here in the positive, most positive, meaning the post. And now I'm going to go up here to the positive going into the motor. I have 625 millivolts voltage drop. Now that's a little bit too much, in all honesty, that is on that circuit, okay? Now I'm gonna do the ground side. I'm always coming back to ground. Now, by the way, how do I really do this on a car? Okay, I'm gonna use my power probe at the battery, right? Make sure I take the connector, touch it to the tip, and I'm going to press the button. Why am I going to do that? Because if it don't blow the 8 amp breaker, I don't have a good connection. Does everyone understand that? A lot of times you're on there and you hear the little beep and it lights up. Doesn't mean you got a good connection. Then I'm going to go to that particular part of the circuit, and I'm going to apply, like on the power side, I'm going to apply power and see if there's a noise change. So right now, we see that there was a problem to the power side, but we have to check the other side, the ground side, okay? So right now, I'm going to go from negative to the next negative up here, meaning the motor negative, and look at the reading. It says OL. So I got to go down to the higher scale. I got 4 volts voltage drop. Sorry, Paul, this will be recorded. I know some of you have to go. It's 5 minutes left, so we will get you out of here at 1 o'clock. So now listen to the difference when I put a ground up there. First of all, you see how the lights came up? Look at my voltage drop where it went down. I just fixed it. Now watch again. I'll take the ground off. Look how high that voltage drop is. 4 volts, right? Fix the ground. Now remember, we still had a positive side voltage drop. So basically, voltage drop is a poor connection. Corrosion, oxidation, breaks of wire strands. Those are all things that prevent things from running correctly, right? Well, hopefully we got a couple other things here to finish up before we go. And one of the things that we have here is we have Dorman mastering the technology. This is Saturday, September 23rd, coming up a couple of weeks away. You may want to show up. You got 3 great instructors besides myself. We got Pete Meyer, Ken Zanders, Oscar Gomez, and myself. You could save yourself $20, okay? Or, I'll tell you what, if you sign up today and use, what's the TST code?
I think it's TST 30.
TST 30, you'll save $30 off the price. You could do the classes with my buddy Oscar in all Spanish. There's an electronic class, and there's one with a diagnosis class. You will get a t-shirt and some other good stuff there. That's one thing we have. Another thing, electronic class. If you're in the tri-state area, you want to come out for a 3-day hands-on class where we go on cars. Don't think we did a lot here today. This is all we can do in an hour. This class here, it is $1,000. You do get, you know, a hot lunch, some stuff to eat in the morning as well, a full color book, and a lot of hands-on, not just slides, but we got 3 full days, 24 plus hours is one thing here, and that is Friday, October 13th, Saturday the 14th, and October 15th from 8 to 4:30ish, okay? We not only cover everything from a test light to a logic probe to meters to graphing meters, but we get into lab scopes. Everyone gets a test board in front of them to actually test stuff out. And if you can't make that, well, look what we have. Did this during the pandemic, a big hit. 6-week online training class, an hour and a half each. It'll be 1 night per week, usually on a Monday. And it will cover a lot of the stuff that we went over in greater detail. There is a way we suggest that you have a little camera. You could buy the whole package. You need to go to the Dorman website to check that out. It's Dorman Training Live. Click on live classes. You could find that all out. You could get the test board. You can get the little camera. And you get a discount if you pay all 6 weeks in one shot, if you do it one at a time. If you don't have the camera, I can't see what you're doing wrong on your end. So everyone's mic at one point will be turned on. We only turn them on when you're asking a question. That way you don't have to type. It's a lot easier. And of course, I can't see you, but you could see me here. But when you got that little camera, I can see what you're doing, right? So we tell you, make sure you got a meter, and we go through the whole board. You'll get different schematics to go through, build a circuit, and actually test it. And then if you want to go into your shop, if you're working in a shop or go on a car, that's great because we will do some on vehicle as well. So not only test board, but by the time we get to the 6th week, 5th, maybe 4th, depending on how everyone comes along, we do that as well. Not as good as being here live and seeing my butt, but hey, close enough if you can't make it, okay? So there's all the information up there. If you have any questions, please type them in. I'm going to move my little monitor here. If you thought this was good, give me a letter Y. If you thought this was a waste of your time, a letter N. We thank you. Don't forget tomorrow, Lunch and Learn heavy duty maintenance inspection, which is an important thing of roadside inspections. So that'll be with my buddy Swede Owen, same time. And we'll be back next month with, I don't know, something, whatever I could think up. If you got suggestions like someone did EVAP, type it in there and we'll see if we can make it happen sometimes within the month or maybe 2 months afterwards. Thank you again for your time. From New York, it's 1 o'clock on the dot. C'est la vie. I'll catch you next time. Thank you again from Dorman Products. I'm G. Truglia. Have a great day.